Hello, dear students. So, first, let me announce Physics King of this week. His name is Srinivas and he's from Vijayawada. He has not posted the answer in the comment section, but he personally messaged me. And also, I don't know him. From where he got my number, that also I don't know, right? But he messaged just 1 hour before he messaged, and he said, "Sir, I'm studying in Vijayawada branch. My name is Srinivas, and that is the right answer. So, and that is the correct answer also, right? So, Mr. Srinivas, congratulations, beta, right? And let's see what is my solution. If your solution is better than my solution, then please post it in the comment section. Don't worry, beta, right? So don't hesitate, okay? So it's not like that. So last time also, one of our student, Mr. R. Aditya, posted answer as well as solution in the comment section. Huh? You can also post, right? So don't worry. Okay. So let's first see the question again. So question was very simple. So capital M was much greater than small m. So means wherever required we can assume, we can consider some assumptions, right? Okay. So now the correct answer is the minimum distance is capital L in bracket small m upon capital M, right? So now here you may think that capital M is much greater than small m, so then it is 1 by infinity form and it is 0. No, it's not like that. Actually, after every collision, what is happening? Velocity of capital M is decreasing, right? So it is decreasing. So there will be one point where velocity of capital M is very less, right? So practically that M mass is not moving at that instant, okay? And at that point we can consider velocity as just 0, because after that again if collision will happen, capital M will reverse its direction, right? So correct answer is this with the considerable assumptions also. Okay, so first let's see what to do. So here in my solution what I am doing, first I am considering that there is at any instant that separation of point of collision from the wall is Ln, right? And just after nth collision I am assuming velocity of heavy mass is Vn and velocity of light mass is Vn dash. That is what I am assuming. And now after this nth collision till this n plus 1th collision, separation between collision point and wall has been reduced to Ln plus 1, right? So now what I am doing with so suppose that ball with velocity v and dash that is moving. So it is covering first Ln distance and now coming back it is covering Ln plus 1 distance, right? So total time taken for this front ball is Ln plus 1 v and dash. All the collisions were elastic. Similarly, this back ball, so how much distance it is covering? Ln minus Ln plus 1. So that distance upon velocity is Vn, right? So now if you are rearranging the term, we are getting a very beautiful relation, right? And then what else we can do? We can make it even more beautiful. How, beta? By linear momentum conservation, right? So that is initial linear momentum, right? So means when after collision it is coming back, so just before the next collision the velocity was like this, and just after next collision the velocities are like this. So between these two collisions I am doing linear momentum conservation and kinetic energy conservation, beta, right? So linear momentum conservation and kinetic energy conservation, just like in collision formula we used to get, the same formula I am getting here, right? So for elastic head-on collision by linear momentum and by kinetic energy conservation, the formula we used to get, that formula I am getting, okay? So now here Vn plus Vn dash, Vn plus Vn dash, this quantity I am writing as Vn1, n plus 1 is after nth collision Vn dash minus Vn plus 1. So dash I am writing for what, beta? This is a front ball, right? So ball in the front, for that I am writing dash, and normal V I am writing for the heavier ball, right? Okay. So now if I am substituting, I am getting even more beautiful result. Very important result we are getting. So what this result is giving us, Ln into velocity difference, okay, is equal to Ln plus 1 velocity difference, right? It means the collision point and relative velocity difference after collision, velocity difference and collision point and ball separation, their product is a constant quantity, right? After nth collision and after nth collision, so this product is always constant. So this should be constant for first and last collision also, right? So that is basically the crux point of this question, right? So that is basically the crux point, the main point of this problem. So there are many problems where we need to rearrange the terms, right? So we have to apply all the concepts of mechanics and then we get a particular pattern. So it is that kind of question, right? So for any collision, above relation is valid. So that I am doing even just after first collision. So just after first collision, I am writing again linear momentum conservation and kinetic energy conservation, the type of equation 3 like this. I am writing for just first collision. So then I can write what? So after nth collision and first collision, right? Because just before first collision, this lighter ball, its velocity was 0, right? So just LV naught, okay? Now, what about this Vn dash? Now, n I am saying here, what collision? When just heavier ball is about to take turn. Velocity of heavier ball is very less and it is about to take turn, beta, right? When separation is minimum. So at that instant, your Vn dash, your Vn, right? So heavier ball velocity is Vn, na, beta? Right? This Vn, na? So this Vn will approach to 0. So this quantity will approach to 0, right? So when that separation is minimum, so for minimum separation, I am writing this equation. Okay, beta. Now all the equations are elastic. So initially only heavier ball had velocity, so its kinetic energy is this, and at your limiting condition, only lighter ball is having velocity, right? So kinetic energy conservation, V naught by V dash, you are getting root of small m by capital M. So minimum distance you are getting this quantity, beta, right? So please see what is the thing that you are missing. Very important question, right? And Mr. Mr. Srinivas, beta, if your solution is better than that or is not that lengthy, then please post in the group. Don't worry, beta. Okay. So yes. Okay, beta. So please post in the comment section if you have any doubt whether you like that question or not. Okay, that also you can write, right? Okay, thank you, beta.